Hi everyone, welcome back to Chem Help ASAP. In this video, we are going to do the type of stoichiometry calculations that you are most likely to do in the lab. So usually in the lab, we are using our balances and we are measuring out grams of reactant and also grams of product we form. So let's see how these calculations work. Okay, here is our problem. We are reacting baking soda and vinegar. We're given a chemical equation, and our question asks how many grams of water are produced when 155.45 grams of baking soda are reacted with an excess of vinegar. So I see that I'm given information on one compound, baking soda, and I'm asked about grams of another compound, in this case water. I must be doing stoichiometry, which means I need a balanced chemical equation. Now I have been given a chemical equation, but let's make sure it is balanced. Let's see, sodiums, yes, hydrogens, yes, carbons look good, and 3, 4, 5, yes, oxygens look good as well. Okay, great. Love it when it's all one-to-one. Now the key thing to remember when you're doing stoichiometry, you always need to be in moles. So the first thing I'm going to do is I'm going to calculate some molar masses. I'm going to calculate the molar mass of water because that's what it's asked for, and I'm also going to calculate the molar mass of baking soda. I use my periodic table and I get both of these molar masses. Now I'm ready to actually do the stoichiometric calculations. So I'm going to start with my 155.45 grams of baking soda, and the first thing I'm going to do is use its molar mass to convert to moles of baking soda. Notice my grams of baking soda cancel and I'm left with moles of baking soda. Now that I'm in moles, I can use my mole ratio to switch from baking soda to water. So I'm switching to a different molecule. Again, love this one-to-one ratio. My moles of baking soda cancel. Here are my moles of water. Of course, the question did not ask me for moles of water. It asked me for grams of water. So this time I'm going to use the molar mass of water. Again, my moles of water are going to cancel. I now have grams of water. I plug all this into my calculator, and here is the number my calculator gives me. Now, rounding to the correct number of sig figs, I will produce 33.336 grams of water. Let's keep with this same reaction, but ask a little different question. So now my question is how many grams of vinegar are required to make 3.5 grams of sodium acetate? So I'm given a mass of product, grams of sodium acetate, and I am asked about a reactant, grams of vinegar. Again, I'm clearly switching molecules, so I need a balanced chemical equation, which I already have. Check. Now let's get some molar masses. I'm going to get the molar mass of vinegar and sodium acetate. I grab my periodic table. Here are my molar masses. Now I'm ready to do my stoichiometry. I'm going to start with what I was given, my 3.5 grams of sodium acetate. And again, because I know stoichiometry must be in moles, my first step is to convert grams of sodium acetate into moles of sodium acetate. Here is my molar mass, my grams cancel. Now I have moles of sodium acetate. I'm ready to use my mole ratio to convert to a different molecule, in this case vinegar. So my moles of sodium acetate cancel. Here are my moles of vinegar. Of course, the problem did not ask for moles of vinegar. It asked for grams of vinegar. So I need my molar mass of vinegar to then convert my moles of vinegar into grams of vinegar. I put this all in my calculator. Here is the number I get from my calculator. But of course, I need to round to the correct number of sig figs. So if I round to the correct number of sig figs, I'm going to get 2.56 grams of vinegar. In these longer calculations, I always like to tell my students, let your units lead you. They will show you the correct path. Now in my next video, we are going to introduce percent yield, and we're actually going to use the calculation that we just did in this one. So I hope to see you there.